Hello everyone. We'll see in this video relationship between activity and mole fraction of component in the binary system of a binary solution. So we know the free energy of the system can be given as can be represented in the form of two components. So this represents the free energy in terms of the elemental components present inside the system, and similarly we have second one as delta G mix term. So delta G mix is given by this is basically we get it by mixing the two of the elements together and by their configuration. So delta G mix is delta H mix minus T delta S mix. So delta H mix is represented by this term, and delta minus T delta H mix term is represented by this term RT XL and XA plus XBL and XB. Similarly, G can be also written as XA mu A plus XB mu B, which is given by Gibbs-Doham equation. Now from this above equation, which I have written here, so if we segregate XA and XB terms, so we can get the value of mu A and mu B. So this is the value which we get when we segregate the terms, and in this way we have developed a relationship between chemical potential and mole fraction. Similarly, we have the relationship between chemical potential and activity, which is given by mu I equal to Gi plus RT ln AI. So AI is the activity of that element. So now if we compare these equations, so I will solve it for mu A. So if we compare the mu A in this both the equations, then we get Ga plus RT ln small a equal to Ga plus omega times 1 minus Xa square plus RT ln X A, which is mole fraction of A. Now Ga gets cancelled, and if I rearrange ln terms together, so I have this relation. So in this way, we have developed relationship between the activity and mole fraction of the component. Now I have written here it in printed form. So now let us consider activity of A upon mole fraction of A as gamma A, which is known as activity coefficient. We can call it activity coefficient. So this equation can be rewritten as ln gamma A equal to omega by RT into XB square, because we know X since XA plus XB is equal to 1. And from this we can rewrite this equation as ln gamma A equal to omega by RT into XB square. Now for ideal solution, we have delta H mix equal to 0, that means omega is equal to 0. And if we put omega equal to 0 in this above equation, then we get ln Ra equal to 0. So here the gamma A should be equal to 1. That means Xa should be equal to activity of A. Similarly, for dilute solution, we obtain same result. For dilute solution, we have Xb tending to 0. If Xb tend to 0, that means ln gamma equal to 0, and that means gamma equal to 1, and that means Xb equal to Xa equal to activity of A. Now if omega is greater than 0 or less than 0, so curve will change its nature. So if I plot the graph in terms of activity versus mole fraction, so if you look at properly, so I will get y equal to x type of curve for ideal solution and dilute solution. So this will pass through origin, but depending upon the sign of omega, we will have a bump in the curve which can be upwards or downwards. So I have represented in graphical manner where I have done the plot of activity of A against XB, and you can see the number 1 shows the relationship for ideal solution, and this type of thing is followed by the Raoult's law, and similarly 3 and 2 shows curve 3 and 2 shows the deviation from the ideal behavior. So in this way we can study the relationship between activity and mole fraction or composition. depending on our given binary system.